Hello guys, welcome to my new video. Our today's question is successful pair of spells and potions. Okay, so you can read this description where I'm going to explain direct. Okay, so for every spell you have to return a count of pairs which are valid. Means for 5, how many pairs after multiplying it is greater than 7. Means for 5 we can make pair with every element, every portions in portions array. Okay, so 5 multiplied by 1, can it is greater than 7 or okay, no. So 5 multiplied by 10 means after multiplied our portions array with spell, that is 5. Okay, after multiplying the 5 the array becomes something like that. Okay, so these are the pair, these are the pairs. Okay, so these are greater than or these are greater than or equal to our success. Okay, so there are 4 pairs, so we have to write 4. Okay, so we have to create answer array of the same length of the spell length. Okay, so for 1 we have to count the pair. So for 1, okay, 1 multiplied by 1 it is not greater than or equal to 7, so we have to count. So we can simply traverse on our portions array multiplied with our spell. Okay, this is the spell strength of the spell. Okay, after multiplying we have to check if it is greater than or equal to success, so we can increase our count. And there are, after multiplying with 1, there are 0 elements that are great, the pairs that are greater than equal to 7, so we can simply write here 0. Okay, after that 3. Okay, after multiplied by 3, let's see, 3 multiplied by 1 it is not valid, 3 multiplied by 2 it is not valid, 3 multiplied by 3, 9, it is valid because 9 is greater than or equal to 7. Okay, and 4 multiplied by 3 it is also valid, and 5 multiplied by 3, 15, it is also valid. So the valid pairs are 3, so we can write over here 3. Okay, now let's understand the question. Okay, now you understand the question, let's start the solution. Okay, I am going to use binary search over here, but for that first we need to understand the question. Okay, so we have to solve this question by using brute force, and after that I am going to optimize that. Okay, like we have to solve this array, portions array, but this is already sorted in the question. Like this is the example, so it is already sorted. To understand this question more efficiently, I just write random numbers. Okay, 1 2, like same element but the index are same, so understand the question. Okay, so we have to first create the answer array of the same length of our spells length. Okay, okay, this is our answer array. Okay, so for spell 0, like spell 0, okay, this is index. For 5 we have to count the valid pairs, right? So we can simply traverse on our portions array. Okay, portions array, so 5 multiplied by 5, yes, so we have to uh, take one variable count. Okay, so 5 multiplied by 5, 25, 25 is greater. Okay, just a second guys. Okay, let's see, 25 is greater than or equal to 7. Okay, this is success. Okay, 7, yes, it is greater, so we have to increase our count. Now count is 1. 5 multiplied by 2, 10 is greater than or equal to 7. Yes, so we have to increase our count. Our count becomes 2. Okay, now can 1 multiplied by 5 it is greater than or equal to 7? No, so we can't increase our count. Now 3 multiplied by 5 it is greater than or equal to 7? Yes, also 4 multiplied by 5 it is also greater than or equal to 7. So our count is 4. Okay, now why we need to sort this? Okay, our count is 4. Okay, so we are simply writing our answer of I is 4. Okay, so why we need to sort the portions? Very simple. Okay, like we are multiplying it. Okay, and we are checking if it is greater than or equal to 7. Okay, so first just sort the array. Why we need this sort, I am going to tell you. Okay, so after sorting the array becomes 1 2 3 4 5. Okay, now we just need to find one valid index. After that everything is valid. Why? Okay, let's dry run. Okay, for 5 multiplied by 1, can it is valid? No, it is not valid. Okay, now come on to the second index, that is, okay, first index means second number, that is 2. So 5 multiplied by 2, can it is valid? Okay, if it is valid, yes, it is valid. It is. Why? 5 multiplied by 10, and 10 is greater than equal to 7, So now this is the first valid index, like after that everything is valid. Why? Because the values are increasing. If we multiplied 3 with 5, the value is going to increase. Okay, it is 15 and 15 is greater than 10 and 10 is valid, that means 15 is going to valid. Like every value for 4 multiplied by 5 is 20 and that is greater, like every value is going to be greater. Okay, so first valid index is 1. So what we can, so how we can count every pair? What is the size of the array? Size of the array is 5. Size of the array is 5. 5 minus first valid index, that is 1. Okay, and that is 4. So we can simply 5 minus 1. Okay, 4. So our answer is 4, right? This is one, this is one optimization. Okay, now let's come on to the one. Okay, for one we have to check first valid index. Okay, 1 multiplied by 1, can it is if it, no, it is not greater than 7. 2 multiplied by 1, it is not greater, it is not valid. Okay, 5 multiplied by 1, it is greater than or 7, no. So the count is 0. So again we are traversing, for one we are traversing entire array. Okay, and the array is sorted, that means we can use binary search. Okay, whenever the array is sorted, we can think, we can use kind of binary search. Why? Because array is sorted, so binary search algorithm always we use on sorted array. Okay, so let's dry run. Okay, so first just erase it. Now binary, we are using binary search. Okay, for 5 we need, what our goal is, we need to find first valid index. Okay, first valid index, that is smallest. Okay, so let's take low value. So low value is 0 and high value, okay, high value is 4. Okay, so our range is from 0 to 4. Okay, this is our range. So I take both index. Okay, now we have to calculate our mid is nothing but high plus low divided by 2 and that is 2. Okay, so mid is 2. Okay, this is the mid. 3, can 3 is valid? Let's check. 5 multiplied by 3, if it is greater than or equal to 7, yes, 15 is greater than 7. So we have to store our index. Okay, this is valid index, so this is 2. Okay, so 2. Okay, this is a valid index. Okay, now let me tell, like 3 is valid, that means every number from index 2 is valid. Why? Because values are increasing, so everything is valid. Okay, like 4 multiplied by 5 is 20 and 20 is greater than 15. Okay, so it is going to valid. Okay, so now we have to decrease our high value to mid minus 1, because this is, we already calculated for it. Okay, we have, and we don't want our answer in this range, we want index as minimum and valid, so we have to decrease our value. Mid minus 1 is 2 minus 1 is 1. Okay, so our high value is 1. Okay, now again we have to calculate mid. So 1, so mid is now 1. 1 plus 0 divided by 2, that is 0. Okay, so our mid is 0. So let's check 0 index is valid or not. 1. So okay, 5 multiplied by 1, okay, it is greater than equal to 7, no, it is not valid. That means every value from 1 to 0. Okay, if there are some positions and there are some values, so everything is from 0 to 1 is like index 0 is invalid. Why? Because these values like are smaller and this value is greatest among all of them. Okay, like from this value is greatest and this is invalid, that means everything from 0 index is also invalid. Okay, so we have to increase our low value to mid plus 1 and that is 1. So now calculate. Mid is 1, mid is 1, that is 2. Okay, let's check. 5 multiplied by 2, yeah, 10. Okay, so 5 multiplied by 2, that is 10. Can 10 is a valid? Okay, 10 is greater than or equal to 7, yes, it is greater than or equal to 7. So our answer is 1. Okay, index is 1, our index is 1. Okay, that is our index. Okay, so this is mid. Now we have to, like from 1 everything is valid, so we have to decrease our high count. Okay, high count to mid minus 1 and that is 0. And now our low is greater than 0, so we can simply stop. And what is our index? Index is 1, so we have to count the valid pairs. So what we can do, the size is 5. 5 minus 1 is 4. Okay, so we are simply writing 4 over here. Okay, this is what we are doing. Okay, now let's code the solution. Okay, I hope you are understood. Okay, so first what we have to do, we have to create a answer variable. Okay, answer is equal to new int of spells. Okay, spells dot length. Okay, so let me create n is equal to spells dot length. Okay, and answer is size of spells length. Okay, and this is like int, not okay, spells dot length, and that is n. Okay, now what we are doing, we are traversing our spells array and counting the valid pairs. Okay, I is equal to 0, I is less than n, and I plus plus. Okay, now for every spell we want the index that is valid and that is smaller as possible, so we are doing binary search. Okay, so we can do index, we want index, so we can call our function binary search with portions array. Okay, this is the array, and what is the spell, so we have to multiply it. Okay, every value we have to multiply with spell strength, and this is the strength. Okay, these are strength. Okay, let me show you. Okay, strength. Okay, these are strength, but for simplicity we are simply going to pass strength. We can pass spell. Okay, instead of strength. Okay, after that we have to pass our success value also. Okay, we have to pass success value to check if it is valid or not. Okay, after that we got the valid index. If traverse like doing binary search, if still we don't got our answer, so we are returning -1. Okay, like let's assume this function will return us -1 if we don't got any valid index, so it will return us -1. Okay, now we have to check if our index, if it is not equal to -1, that means it is a valid index. So for answer of I is nothing but what is the size of portions. Okay, is size of the portion minus index. Okay, to calculate all the valid pairs. Okay, and first of all we have to sort. Okay, arrays dot sort our portions. Okay, so we have to sort our portions array, we are doing binary search. Okay, so we have to sort it first of all. Okay, after that, so this is our answer, and after that we can simply return our answer. Okay, so we have to now write our binary search function. Okay, binary search, it is taking spells. Okay, what is the first portions. Okay, so portions array, another is spell, this is the strength actually, and third variable is long, in the long. Okay, the third variable is long, so long success. Okay, this is the success, so we have to write our binary search function. Okay, so low value is 0, high value is portions dot length -1. Okay, and we have to calculate index. Okay, valid index -1. Okay, if we don't got any valid index after doing binary search, so we are simply returning our index. Okay, return idx. Okay, now let's do binary search. Okay, so while our low value is less than or equal to high, okay, we have to do binary search, we have to find mid. Okay, mid is nothing but high plus low divided by 2, but this is not the standard practice, this is the standard practice, like low plus high minus low divided by 2, this avoids overflow. Okay, so this is the standard practice. Okay, after that we have to check if it is valid or not. Okay, like what we have to do, spells like positions. Okay, so mid, this is like index. Okay, so positions of mid. Okay, this can be valid, so multiplied with strength, and strength is like spell. Okay, let's take this strength. Okay, strength. Okay, so multiplied with strength, so position. Okay, the position of mid means like any portion in our portions array. Okay, like can be 3. Okay, 3 multiplied with strength, strength is 5, so 15. Can it is valid? How we have to check? If it is greater than or equal to our success, if it is greater than or equal to success, that means it's valid. So our first valid index is mid. Okay, and like after that, okay, if it is valid, like mid value is valid means everything from mid to end is valid, because values are increasing. So Now so we calculate this, so we can eliminate this range. Okay, so how we can do that? We can simply write height is equal to mid. Okay, high is equal to mid minus 1. Okay, now else if this is not valid case, okay, let's check for 1. Okay, if the strength is 1, okay, so mid is 3 multiplied by 1. If it is not valid, okay, that means from 0 to mid everything is invalid. Okay, like 1 2 3 everything is invalid because these values are smaller. So if we multiplied it with 1, the value is going to decrease, okay, not increase. So everything is invalid, so we have to increase our quotient strength. Okay, our quotient strength, and that we can do with low is equal to mid plus 1. Okay, now at the end we are returning our index. Okay, and what is the time complexity? First let's try to run it. Okay, what's the problem? Can't spoil. Okay, spells, this is strength and this is spells of I, not actually spell. Okay, and this is spells. Okay, let's try to run, and let's discuss the time complexity. Okay, this is running. Let's discuss the time complexity. Like first we are sorting the array. Okay, so sorting the array takes an log n. Okay, so let's discuss log n. Okay, this is log n. Okay, like n log n. After that what we are doing, we are traversing in our spells array. Okay, so spells array is n. Okay, and this is m. Okay, not actually n, because we are sorting our portions array. Okay, so portions array length is, let's take m, and after that we are traversing in our spells array, that is n. Okay, for every n what we are doing, we are doing binary search. Okay, we are taking one index that is valid, so we are doing binary search, and binary search time complexity is log n. Okay, so this is the time complexity, and it is going to be accepted. Okay, let's try to run it. Okay, yeah, so we have to comment it now. Wait, let's try to run it or submit it. If you are new to channel, make sure to like, share and subscribe. And okay, what? Wrong answer? How? 1 second. So the problem is we are multiplying this value. Okay, position of mid with strength, and the success is in long, and this value can overflow. Okay, so for that we have to take also strength in long. Okay, so now let's try to run. Yeah, it is running, and it is also running for the edge case. So let's try to submit it now. Okay, if you are new to channel, make sure to like, share and subscribe, and if you have any doubt, make sure to comment. Okay, it's beat 50%. Okay, it's like most of the users are here actually. Okay, thank you so much for watching.